Okay, so today we're going to talk about force diagrams. And so force diagrams are simply visual representations of the forces that are acting on an object, all right? And there are a couple of rules that you need to keep in mind, and we'll go through those as I talk about a couple different situations, all right? Now, for iGCSE, you're only going to be looking at forces that act in direct opposition to each other or are going in exactly the same direction. So you don't need to worry about things on angles or anything like that, all right? So let's take, for example, a ball that is sitting on a surface, okay? Now, this is not accelerating. It's not moving at all. And so that means that the forces acting on it must be balanced. All right. If you remember this equation here, right, the idea is that if there's an acceleration, it means there's an unbalanced force acting on a mass. All right. This one is not accelerating. And so there must be the forces acting on it must be equal and they must be in opposite directions. So the first force that's um, acting on this is acting downwards, and it is the weight of the object. All right, you can label that W, you can label it force of gravity if you want, but please don't label it just gravity. Remember that, again, let me go back to these equations here, right? Weight is measured in newtons. So weight in physics is the equivalent of the force that something is exerting. So the weight arrow should always be drawn directly downwards towards the center of the earth. And it should also start at the center of gravity from this object. So this is a round object, it's going to start about right in the middle. All right. But if that were the only force, that would be an unbalanced force. So there must be another force acting in the opposite direction. All right. And so for that one, this is going up. So it's an arrow going up, and it should be about the same size because these forces are equal. All right. And this is called the normal. Sometimes it's called the normal reaction force. And normal simply means at this point it's perpendicular. It's always at a 90-degree angle from the surface, right? So if this is the surface and this is the normal, you have a 90-degree angle here. If you remember the waves unit, all right, that we've done, the normal is the imaginary line that's perpendicular to the surface of the medium where the wave is entering. And so this is the same thing. It's a normal. So it's always acting perpendicular to the surface. All right. And so, as I said, these arrows should be about the same length because they are equal. Okay. Now, what if we take an object that is still on a surface but is moving? Okay. So let's say I can't draw much other than a ball. So we're going to stick with another ball. Okay. So we have a ball. Okay. And so, but it's moving. And so the idea is that if it's moving in this direction, okay, it's rolling, for example, like this, then we're still going to have the two, that we're going to have its weight, and we're going to have the normal. Okay. But now, since it's in motion, it's going to have another force acting on it. And the force that opposes motion on the ground is what we call friction. And so it opposes motion. So if the ball is rolling this way, then the friction is going to be going the opposite way. And you can draw it on the ground itself here, or you can draw it up. It doesn't really matter. So I'm going to draw mine on here, and this would be labeled friction. Okay. Now, if you had a car, which I can't really draw, but if you had a car that, for example, had a motor force, there would be a fourth force acting on it in this direction because the motor force or the driving force is actually pushing it right against the friction. All right. So this one has three forces, and you notice that these two are balanced. They're both the same, but the friction is unbalanced. And so what that means is that eventually the ball is going to stop rolling because there is no force that is acting in the opposite direction as friction. So there's no motor in this ball that is pushing it along, for example. Okay, and so eventually the ball will stop and roll because the friction is acting as an unbalanced force. Right. Let's see. The other type of force diagram that you often get is something that is in free fall. So again, if we have a ball, okay, and so it's falling, it's been dropped, it's falling in this direction. You still have the weight pulling it down, okay? And then in the air, if you're not on a surface, you still have, there's always a force that opposes motion, and that's called air resistance or drag, okay? And so that would be going up here, and you can name it drag or air resistance. Those two terms are interchangeable, okay? Now, but notice that here I've drawn my drag arrow shorter it's smaller, right? It's not as long as the weight, okay? So this tells me that the forces here are unbalanced, all right? And the net force is going to be in the direction, the overall force is going to be in the direction of the bigger arrow. So this ball does not have balanced forces acting on it. Instead, it is accelerating, okay? And the acceleration is going to be in a downwards direction, because this arrow is larger. So when you're drawing these force diagrams, you want to make sure that your arrows are clearly labeled, okay? Everything needs label. And you also want to make sure that the size of the arrows are telling you something. So if the arrows are the same size as they are here, that means the forces are balanced. So something either isn't moving or it's moving at a constant velocity, okay? Whereas here, the idea is that this ball would be accelerating downwards because there's an unbalanced force, all right? And so, for example, let's say that the force acting upwards is 40 newtons. Okay, that's the force of the drag. The weight might be, say, 60 newtons. All right, and so the overall force, the unbalanced force acting on this, would be 20 newtons downwards in the down direction. Okay. Oops. So the idea is, because it's the 60 minus the 40, they're acting in opposite directions, so you subtract them. If they were acting in the same direction, you would add them, all right? And so the idea is that as long as you have this force, this unbalanced force, then you're going to have acceleration. And the unbalanced force, you can call it unbalanced force, it's also often called the resultant. Oh, you can't see, sorry. Resultant force. Okay, so the resultant force is the unbalanced force. So if there is a resultant force on an object, it will be experiencing acceleration. Okay.